Here are 14 practice problems on special right triangles. As per usual, I'll link these questions and the answer key in the description, so if you want to work ahead, you can go ahead and do so. But if you need a little bit more help, I will be going through every single question. Or if you need further clarification, feel free to ask me. Now before we get started, if you go ahead and look in the bottom right hand corner, you'll see that special right triangles are actually on the reference sheet on the SAT. So you don't need to memorize 30, 60, 90 triangles or 45, 45, 90 triangles unless you really want to. Anyways, let's get started with question number 1. A graphic designer is creating a logo for a company. The logo is shown in the figure above. The logo is in the shape of a trapezoid and consists of 3 congruent equilateral triangles. If the perimeter of the logo is 20 centimeters, what is the combined area of the shaded regions in square centimeters of the logo? So here our shape is a trapezoid, but really it's just 3 triangles. And if you go ahead and look in the bottom right hand corner, you'll see that the formula for the area of a right triangle is 1/2 base times height. So let me just write that up here. Now let me enlarge this picture a little bit. Alright, so here we have our trapezoid with 3 equilateral triangles, and remember an equilateral triangle will have 3 equal sides. So I'm gonna color this in blue, so you have all these sides being equal to each other. And then you also know that each of these angles are all 60 degrees. So these are all 60 degrees. Now the first thing you want to do when you have an equilateral triangle is to split it in half. And the reason for this is because now you have split this 60-degree angle up here into 2 30-degree angles, and you also just created a 90-degree angle here on the bottom. So you pretty much just created a 30, 60, 90 right triangle. Alright, now our next piece of information is that the perimeter of the logo is 20 centimeters. So that means if we take all of our sides and add them up, they'll equal 20 centimeters. So real quick, let's count how many sides we have. We have this side right here, that's 1. This side right here, that's 2, 3, 4, and 5. So that means that there's 5 total sides. So if we take our perimeter and divide it by the number of sides, we get that each side length is equal to 4 centimeters. So this would be 4 centimeters up here, 4 centimeters here, 4 centimeters here, 4 centimeters here, and 4 centimeters here. Alright, and remember we did cut this triangle here on the left in half, which means that the whole side length of 4 centimeters is now going to be split into this part right here, which is 2, and then this part right here, which is another 2. Okay, now our next step is to find out the length of this height right here. And to do that, let's go ahead and look in the bottom right hand corner and see the rule for 30, 60, 90 triangles. We know that across from the 30-degree angle, that's going to be x. So here x is equal to 2. And then across from the 60-degree angle, that's going to be x square root 3. So that means that our height is equal to x square root 3 or 2 square root 3. Now to find the area of this triangle, we're going to use 1/2 base times height. So let's put this in desmos, 1/2. Our base is going to be 4 because remember it's going to be the base of the entire triangle. And then multiplied by the height, which is 2 square root 3. Now they want us to find the combined area of the shaded regions. And if you look up here in this picture, there's 2 triangles that are shaded. So we're going to multiply this by 2. And now all we have to do is plug in each answer choice and see which one matches. So first up, answer choice A, 2 square root 3, that's not the same. 4 square root 3, that's not the same. 8 square root 3, that is the same, which means our answer is C. Question number 2. The perimeter of an equilateral triangle is 624 centimeters. The height of this triangle is k square root 3 centimeters, where k is a constant, which means it's a number. What is the value of k? Alright, I don't know why all my lines are like slanted downwards, but anyways, let's go ahead and draw in this equilateral triangle. Okay, so here's equilateral triangle, and once again, an equilateral triangle means that all 3 of its sides are going to be equivalent, and that all 3 of its angles are going to be 60 degrees. Okay, so we know that this triangle has a perimeter of 624 centimeters. So if you take all of its sides and add them up, it'll equal 624. So this time, we know it's just one triangle, which means it has 3 sides. So if we take the perimeter and divide it by the number of sides, which is 3, we get that each side is equal to, let me put this in desmos, 208 centimeters. So this is 208 centimeters, this is 208 centimeters, and this is 208 centimeters. Now remember, whenever you get a equilateral triangle, you always want to split it in half, so you can create that 30, 60, 90 special right triangle. Okay, I can't get it in half. There we go. So we know that this top 60-degree angle is now split into 30 degrees, and they also give us the height of the triangle, which is k square root 3. Okay, now that we split the triangle in half, we also split the base in half, so that means that this is now 104, and this is also 104, to create a total of 208. Now to find the value of k, all we have to do is use the rules for special right triangles. We know that the side across from the 30 is x, so that means our 104 is equal to x. And then we know that the side across from the 60-degree angle is x square root 3. So that means that k square root 3 is equal to x square root 3. And I think you can see where I'm going with this. We know that x is equal to 104. So 104 square root 3 is equal to k square root 3. And yeah, k is equal to 104. I was trying to make it as obvious as possible. Question number 3. For the triangle shown, which expression represents the value of a? So here we have a right triangle and they're asking us to find the missing side. So to do that, all we have to use is Pythagorean theorem. So this isn't a special right triangle and I'm not sure why this is here, but at the same time I'm too lazy to move it, so you're welcome, I guess. Now you don't even need to memorize the Pythagorean theorem, although I'm pretty sure all of us have it memorized at this point. But once again, it is in the reference sheet in the bottom right hand corner. So a squared plus b squared is equal to c squared. And then to get a squared by itself, let's subtract b squared from both sides. To get a squared is equal to c squared minus b squared. And then to get a by itself, we're going to take the square root of both sides and get that a is equal to the square root of c squared minus b squared. Now let's go ahead and substitute in our values. We know that the c value is our hypotenuse, which is 21, and then our b value is just the length of the other side. So a is equal to the square root of 21 squared minus 6 squared, so that means our answer is a. Question number 4. An isosceles right triangle has a hypotenuse of length 58 inches. What is the perimeter of this triangle? So here we have an isosceles right triangle. Let me quickly draw this in. We know it's an isosceles triangle, so that means that its two sides, well, it will have two sides that are congruent. It's a right triangle, so that means it has a right angle. And since it's an isosceles triangle, that also means its base angles, so these two, are congruent, which means they're both 45 degrees, making this a 45, 45, 90 triangle. Now we also know the hypotenuse is 58 inches, so let me quickly write that down. And now to find the two side lengths, we can use the rule for 45, 45, 90 triangles. So let's go ahead and look in the bottom right hand corner. We know that the hypotenuse is equal to s square root 2, okay. For some reason we swapped from x's to s's, but okay. Alright, and then we know that these two other side lengths are each s. Now you could solve for s by hand by dividing by square root 2 to get s by itself, but that also requires rationalizing and I don't want to do all that work. So instead, let's just put this in desmos. So 58. Instead of an equal sign, you want to put a tilde, and then s square root 2, and you get the value of s there. And then now all you have to do is add up all your side lengths. So you would do s plus 58, and you get this number 140.02. And now all we have to do is plug in answer choices until we get one that matches. So here's answer choice A, 29 square root 2. That's not the same. B, 58 square root 2. That's not the same. C, 58 plus 58 square root 2. That is the same, which means our answer is C. Question number 5. An isosceles right triangle has a perimeter of 94 plus 94 squared 2 inches. What is the length in inches of one leg of this triangle? So here we have another isosceles right triangle, so let me quickly draw this. And once again, we know an isosceles triangle has two equal sides. It's a right triangle, so it has a 90-degree angle. An isosceles triangle also has two equal base angles, which means both of these are 45 degrees, making this a 45, 45, 90 triangle. Now, if we go ahead and look in the bottom right hand corner, 45, 45, 90 triangles, the hypotenuse is going to be s square root 2, and the two side lengths are going to be s each. We also know the perimeter is 94 plus 94 square root 2 inches. So if we add up all of our sides, it should equal that perimeter. So let's go ahead and do that. We would do s plus s square root 2, and that would be equal to 94 plus 94 square root 2. Okay, that cut off, but the goal here is to get s by itself. Now you could do this by hand, but you would end up having to divide by square root 2, and then you would have to rationalize, and that's a whole bunch of work, so instead, let's put it in desmos. So we would do s plus s square root 2, and instead of an equal sign, you want to put a tilde, and then 94 plus 94 square root 2. And then you get the value of s is equal to 66.5. Now all that's left is to plug in answer choices until you get the right one. Although this one's going to be pretty obvious. I mean, it's obviously not 47, it's obviously not 94, and then once again, it's obviously not going to be a number bigger than 94, which means your answer is B. And if we go ahead and plug this in, 47 square root 2, it is 66.5. Question number 6. A right triangle has legs with lengths of 24 centimeters and 21 centimeters. If the length of the triangle's hypotenuse in centimeters can be written in the form 3 square root d, where d is an integer, which means it's a number with no decimals, what is the value of d? So here we know we have a right triangle, and we know that one side has a length of 24 centimeters, the other side has a length of 21 centimeters, and the hypotenuse has a length of 3 square root d centimeters. And it's a right triangle, so let me put my right angle here. Once again, we're trying to find a side in a right triangle, so all we have to do is use Pythagorean theorem. This once again is not a special right triangle. I don't know why this is here. I guess I was really lazy when I was making this, but I'm still lazy now, so I'm not changing it either. So once again, the Pythagorean theorem is a squared plus b squared is equal to c squared. So let's go ahead and plug in our values. We have 24 as A, 21 as B. A and B don't really matter. The only thing that matters is that C is our hypotenuse, of course. So you'd have 24 squared plus 21 squared is equal to 3 square root d squared. Now you could solve this by hand, but we all know I'm a big fan of desmos, so let's put this in desmos. Instead of an equal sign, you want to put a tilde, and then continue typing as normal. And there you go, you get that your answer is 113. D equals 113. Question number 7. A right triangle has legs with lengths of 28 centimeters and 20 centimeters. What is the length of this triangle's hypotenuse in centimeters? Oh my goodness, we have another right triangle. So we have a right angle here. We know that it has side lengths of 28 centimeters and 20 centimeters. And we're trying to find its hypotenuse, so we're trying to find the missing side in a right triangle, and to do that we'll be using the Pythagorean theorem. At this point it should be special right triangles and Pythagorean theorem, but the problem is, I haven't done the other triangle one, so I don't know if I include Pythagorean theorem in those either. Anyways, the Pythagorean theorem is a squared plus b squared equals c squared, or you can look in the bottom right hand corner. This of course is going to be c, because that's your hypotenuse. And now you can go ahead and start plugging in values. It doesn't really matter what you use for A or B. So 28 squared plus 20 squared is equal to c squared. And now you can solve this by hand, or let's put it in desmos. 28 squared plus 20 squared. Instead of an equal sign, you want to put a tilde, and then c squared. and you get the value for C here. We know for sure it's not gonna be C 48 or D 1184. So now we just have to test out A and B. So here's A, 8 square root 6. That is not the same. And here's B, 4 square root 74. That is the same. So that means our answer is B. Question number 8. In triangle ABC above, what is the length of line AD? So that's gonna be this side right here. Now we see a 30-degree angle, a right angle, and a 60-degree angle. So this is obviously a 30, 60, 90 triangle. Now across from our 90-degree angle, we have a side length of 12. And if we go ahead and look in the bottom right hand corner, we know that across from the right angle is 2x. So 12 is equal to 2x. Now we also know that across from a 30-degree angle is x. So here's our 30-degree angle, and across from it is x. So we know that 12 is equal to 2x, and we're trying to find x, so to get x by itself, you just divide by 2. And then you get that x is equal to 6, which means our answer is B. Question number 9. The length of a rectangle's diagonal is 3 square root 17, and the length of the rectangle's shorter side is 3. What is the length of the rectangle's longer side? So here we have a little rectangle, and we have a little diagonal going through it. And they tell us that the length of the diagonal is 3 square root 17. Then they tell us that the length of the shorter side, so that would be this side right here, is 3. And now they ask us to find the length of the longer side. So here we have a rectangle, and we know that our rectangle has 90-degree angles. So we have a nice little right triangle here. So now we're trying to find the missing side in a right triangle. And to do that, of course, we'll be using the Pythagorean theorem. Okay, it's actually not even a joke anymore. Anyways, Pythagorean theorem, a squared plus b squared equals c squared. This can be a, this can be b, and of course the hypotenuse is always c. Now let's plug in our values. 3 squared plus b squared is equal to 3 square root 17 squared. I kind of ran out of space there. Now you could do this by hand, or you could just go ahead and put it in desmos. So 3 squared plus b squared. Instead of an equal sign, you want to put a tilde. And then 3 square root 17 squared. And then you get that the length of the longer side is equal to 12. Question number 10. The length of a rectangle's diagonal is 5 square root 17, and the length of the rectangle's shorter side is 5. What is the length of the rectangle's longer side? Wow, it's the exact same question, except this time, they changed up the numbers and you have answer choices now. That is just great. So once again, we have a rectangle and a diagonal going through it to make 2 triangles. Oh man, the rectangle didn't look as nice this time. Anyways, the diagonal is 5 square root 17. The shorter side, which is this one right here, is 5. And we're trying to find the missing side here. Once again, a rectangle has right angles. So we're trying to find the missing side in a right triangle. And to do that, we'll be using the Pythagorean theorem. E squared plus b squared equals c squared. This 5 can be the a, this x can be the b. And then of course the hypotenuse is always the c. So this would be 5 squared plus b squared is equal to 5 square root 17 squared. Now let's put this in desmos. 5 squared plus b squared. Oops. Instead of an equal sign, you want to put a tilde. And then 5 square root 17. That's not a 17. Squared. And we get that b, the length of the longer side, is 20. So our answer is B. Question number 11. A square is inscribed in a circle. The radius of the circle is 20 square root 2 over 2 inches. What is the side length in inches of the square? Alright, so here's my beautiful illustration. We have a square inscribed in a circle, which is literally just a square inside of a circle. And then this dot in the middle represents the center of the circle. Now, when we're drawing the radius, you always want to draw the radius diagonally. Okay, and then let's go ahead and draw the second radius. And as you can see, the reason you want to draw the radius diagonally is because it creates a beautiful little triangle. Let me move that center so it looks a little better. Alright, now they tell us that the radius of the circle is 20 square root 2 over 2 inches. So that means this first radius is 20 square root 2 over 2 inches. And then this second radius here, is also 20 square root 2 over 2 inches. Now, this is a square, which means this right here is a right angle. Well, as a matter of fact, all of the angles are right angles. And since we drew a line through these two right angles here, that would create two 45-degree angles. So now we have a nice little 45, 45, 90 triangle. If you go ahead and look in the bottom right hand corner, you see that in a 45, 45, 90 triangle, the hypotenuse is equal to s square root 2. So this entire hypotenuse here, which includes both of the radii added together, is equal to s square root 2. And then the side lengths are equal to s. So once again, for the hypotenuse, you would have to add both of these radii together, or you could just multiply them by 2. So let's go ahead and put this in desmos. You would do 2 times 20 square root 2 over 2. And then instead of an equal sign, you put a tilde, and then s square root 2. And you get that s is equal to 20, which means our answer is A. Question number 12. In the right triangle shown above, what is the length of line PQ? So they're asking us to find the length of this side right here. Now we see a right angle and a 30-degree angle, so this is obviously going to be a 30, 60, 90 triangle. Now if we go ahead and look in the bottom right hand corner, you'll see that in a 30, 60, 90 triangle, across from the right angle is going to be 2x. So here 8 is equal to 2x. Now across from the 30-degree angle is going to be x. And that happens to be the side we're trying to find. So let's go ahead and solve for x. We know that 8 is equal to 2x. And then to get x by itself, we just divide both sides by 2. And we get that x is equal to 4. Question number 13. In the figure above, line BD, so this line right here, is parallel to line AE, so this line right here. What is the length of line CE? So we're trying to find the length of this line right here. So here in our figure, you'll notice that there are two triangles. You have the smaller triangle, triangle DCB, and then the larger triangle, triangle ECA. So here we actually have a set of similar triangles. Now there should be in angles and triangles, not special right triangles, but you know, I guess I was like on something when I was making this. Anyways, we have a set of similar triangles. So what that means is that their sides are proportional. So they took the smaller triangle and then they scaled it up by a certain number to get the larger triangle. Now what we need to find out is what is that number they scaled up by. Alright, so I went ahead and redrew our two triangles, but I just drew them separately. On the left you had the smaller triangle, DCB. On the right you have the larger triangle, ECA. So when you're trying to figure out which side corresponds to which side, you always want to be thinking that the smallest side will go with the smallest side. So the smallest side in the left triangle is going to be this one right here. And then the smallest side in the right triangle is going to be this side right here. So let me actually color that in blue. I don't know why I chose the same color. So this side right here. Actually, let me just highlight it. Why am I circling? Alright, so this side right here goes with this side right here. That means that the 6 will correspond to the 8C. And I think you can tell where this is going. All they did was multiply by 3. Now let's go on to our middle side line. Now that's obviously going to be this side, because your hypotenuse is always going to be your longest side. So that means that this side CB is going to correspond with this side right here. And to find this number, all we're going to do is multiply this 8 by 3, just like they did to go from 6 to 18, they multiplied by 3. So 8 times 3 is going to be 24. So let me get all that. This is going to be 24. So now you have two ways of going about this. You can either find the hypotenuse here and then scale it up to go over here. Or you could just use these side lengths and find the hypotenuse using the Pythagorean theorem. Actually, you also could have just completely skipped this step and then found the hypotenuse and moved it over here. There's like a million ways that you could have went about this. Alright, so I'm gonna just go ahead and put the right triangle into Desmos. So to find the missing side length, obviously we're going to be using the Pythagorean theorem, a squared plus b squared equals c squared. Now you could also notice that this is a Pythagorean triple, but in case you don't want to memorize all of those, let's just put it in Desmos to be safe. So 18 squared plus 24 squared, and instead of an equal sign you want to put a tilde, and then you would put c squared, and we get that the value of c is equal to 30. So that means 30 is our answer. Now you could have also found the hypotenuse on this side right here, and this one it's like extremely easy to tell it's a Pythagorean triple because it's a 3, 4, 5 triangle scaled up by 2. So you could either tell that this side would just be 10, or you could have also put in Desmos 6 squared plus 8 squared. Instead of an equal sign you want to put a tilde, c squared, and you get that that side length is equal to 10. And then to move it over here, you would scale it up by a ratio of 3. So in this triangle, it was really easy to tell which side corresponded with which side. I mean, the vertical one went with the vertical one, and also told you that BD was parallel to AE, but this won't always be the case. So you always want to make sure that you pair the smallest side with the smallest side, not the side that's vertical with the side that's vertical, because it won't always work out. Question number 14. A triangle with angle measures 30, 60, and 90 has a perimeter of 18 plus 6 square root 3. What is the length of the longest side of the triangle? So here we obviously have a 30, 60, 90 triangle, so let me quickly draw that. Alright, so here's the 30, 60, 90 triangle. Now, if you go ahead and look in the bottom right hand corner, you see the rules for the 30, 60, 90 triangle. Across from the 30-degree angle is going to be x. Across from the 60-degree angle is going to be x square root 3. And then across from the right angle is going to be 2x. Now we know that all of these sides will add up to our perimeter of 18 plus 6 square root 3. So let me quickly write that down. You would have x plus 2x plus x square root 3 is equal to 18 plus 6 square root 3. Okay, I always manage to run out of space. Anyways, now they're asking us to find the length of the longest side, and the longest side will always be the hypotenuse, so we have to find the value of 2x. Now first off, before we do that, we also have to find the value of x, and you could do that by hand using algebra, or we could always just put it in Desmos. So here, x plus 2x plus x square root 3. Now since we're using x's, and as you can see it's actually graphed, let's just put an equal sign instead, and then 18 plus 6 square root 3. And then you see that the value of x is going to be 6. So 2x would be equal to, okay, I don't know why I thought that would work. 2 times 6 is equal to 12, which means our answer is 12. Now the reason you want to put an equal sign is because you used x's. Now if you used any other letter but x or y, so let's say we used a, then you would want to put a tilde instead, and it would work. Now there's also a workaround this. You could put it like you were making a regression equation, so you could have put a 1 after all these x's, and then put a tilde, oops, and it would also work like that. Alright, so that was 14 practice problems on special right triangles, but really also Pythagorean theorem, and for some reason one similar triangle as well. As you can see, Desmos is going to be an extremely big help, because you do not want to be dividing by square roots and then having to rationalize that. That's going to be a whole bunch of work. Also, you don't need to memorize the rules for your 30, 60, 90 triangles or your 45, 45, 90 triangles, because it will be on the reference sheet. Now there is going to be like one thing that you should remember, other than like the whole similar triangle thing, and it's going to be that, oh, you should always draw your radiuses diagonally, that way you create a triangle. And then up here, at the very top, remember whenever you have an equilateral triangle, you always want to split it in half, so you can make that 30, 60, 90 triangle. And whenever you have an isosceles triangle, right here, you should know that you're always going to be dealing with the 45, 45, 90 triangle. Alright, that's going to be it. Good luck studying, and I'll see you.